Okay, let's get started. Unit 1, Lesson 1, Solving Systems of Equations. Now we're going to look at this today, and we're going to look at graphing, substitution, and elimination specifically. Later on in the week we're going to get into matrices. So today let's kind of get into the definitions of what we're looking at, review the stuff from Algebra 1 a little bit, and then we'll expand on it later in the week. So today we'll keep it simple, and we'll go through our first 3 steps. Okay, first thing we're going to look at is our definitions. A system of equations is a collection of 2 or more equations with the same set of solutions. Okay, those solutions on a system of equations is going to be where the equations intersect. So on the graph, when you put them together, it's going to be that spot where they cross on the graph. Okay, we're always going to write these solutions as an ordered pair. The ordered pair is always going to be in your XY format that you see right here. That was an ugly Y, I apologize. Okay, the next thing that we're going to do is we're going to look at the 4 different types of solving. Okay, the first solving that we're going to focus on today, and we'll go through quickly, is going to be graphing. The second one we'll do is substitution. We'll have elimination. And then later this week, we'll hit up the matrix here. Okay, those are going to be our 4 different types that we go through. First one we're going to look at today is going to be our graphing systems. Now with graphing systems, you always want to make sure that you're in the slope-intercept form. So you want to be able to recognize your slope right there at M and your y-intercept as the B. So each one has to be in this format. Right here you guys can see that our first equation is not in the proper format. So we need to make sure we move it over and it's ready to go. So what we're going to do is we're going to subtract the 4x here. Let me rewrite it so we can look at it. We're going to move that 4x over to the other side by subtracting a 4x on both sides. That'll leave us with a y. That'll give us a negative 4x plus a 10 on the other side. Now we have the slope-intercept form for both of our equations. We have our equation here and then our original equation up there. Next thing you want to do is you want to come over here and you want to graph it. On this one, after you graph the lines, it's actually going to come through and enter through right here at about 2, 2 to give them both. Okay, so what you would do first is you're going to look at your y-intercept. So we have 10 would be your y-intercept for the equation that we changed. So we're going to be up here somewhere. And it's going to go down 4 and then over 1 right there. Okay, so our line, when we connect all of our dots, and just bear with me on whether or not this line even works right. Okay, pretty rough, but it'll work. Okay, so that's what we're looking at. The next one, you have your y is equal to 5x minus 8. So you want to go to your first point, which is a negative 8 for your y-intercept. So it's going to be about right here. And we're going to go up 5 into the right 1. Puts us right here. And then 1, 2, 3, 4, 5 there over 1. Puts us right at our intersection. So our line is going to go down to those points. So our intersection that we're looking for is going to be 2, 2. And that's how we found our solution to the 2 problems. And what you can do to go back and check is you can plug these in for your x and your y value. Plug them back into each equation, and it should give you the correct answer equal on both sides of the equal sign. So that's how you do it with graphing. If you guys have questions about this, make sure you post it here at the end of the video, or you come up and ask me here in class. Next one was substitution. Now substitution, you can keep one in the slope-intercept form, the other one can be in standard form. You can see the first equation here we have is slope-intercept, the second one we have is standard. Standard is going to have the x and y on the same side of the equal sign. On substitution, what you're paying attention to right now is your y variable. That y variable is going to go through and you're going to enter whatever's on the other side in for your y. So this 2x minus 3 is going to be plugged in for your y in the second problem here. So you have a 3x. Wherever you see that y, you can always put the parentheses, and you have your new equation. Okay, you see that we've eliminated the y value here, so we're only looking for the x. So we're going to go through and just solve this. Just follow our normal steps like we practiced the other day in class. That negative sign on the outside is going to change this to a positive 3. Combine our like terms. And now we've solved for x. Subtracting 3 on both sides here will give us our 1. So now we know that our x has a value of 1. We can take this value now and plug it back into our first equation with the 2x minus 3. But in place of the x, we're going to go ahead and put our 1. And go ahead and solve it out for the y. So our y is going to be equal to negative 1. So as we go through and we look at this, you guys can take these two values, which we're going to write as an ordered pair right here. Okay, that's going to be our answer for this equation. You can go back and plug both those in for the x and y, and that's how you're using substitution. You're taking your slope-intercept form, you're plugging that in for the y, and then you're finding your value for the new variable. Okay, next one, and last one we're going to look at today is elimination. Elimination can be the hardest one, but it also can be pretty simple. All you have to do is kind of recognize which one you want to eliminate first. So if we look at this problem here, we have two equations to make our system. We need to make sure we're eliminating some variable in this. The best way to do it is try to find one that maybe is a positive negative that you can easily multiply. So on this one we have a 2x plus a y is equal to 8. What we want to do is try to eliminate one of these variables by using this second equation. So on the second equation, to me the easiest part to do would to go ahead and eliminate the y, since they both already don't have a coefficient on the front, by making this one over here in the second equation a negative y. I'm going to do that by multiplying this entire equation by negative 1. So it's going to make my x become positive, my y will become negative, and that means my negative 1 on this side is going to become positive. We multiplied this equation here. We acted like we were doing just a negative 1 outside of it. Okay? So now you can see that these will eliminate each other if we go ahead and add these together. So we get a 3x. These will eliminate. A 1 minus a 1 is a 0, so we don't need to put it. And 8 plus 1 is going to be 9. Divide both sides by 3, and we get x is equal to 3. Now, we need to find our y value still. So we're going to go back and we're going to plug this x into one of these equations, whichever one looks to be the easiest. I'm going to go ahead and look at the first one. We have 2 times the 3 that we found with our value. And we're going to solve for y now. So we have a 6 plus y is going to be equal to 8. Subtract 6 on both sides. We're going to get y is equal to 2. So our new answer becomes a 3, 2. That's an ugly 2. There we go. So, ordered pair 3, 2 is going to be the intersection between our two equations, and it's going to be a solution for both systems. So when you look through, today we went through graphing, substitution, and elimination, each one finding a common solution for each system. Today we're going to go ahead and practice that, and later on we'll kind of advance it into matrices. If you guys have any questions, be sure to ask me, and we will get through anything you guys need. I appreciate your time.